All right, this is our lesson on polynomial division. And we're going to go back to long division, like you might have learned in elementary school. And if you're looking at your notes, you're looking at these three division problems which have already been solved. And in each case, we're dividing 330, which is called our dividend, by a number. And the number that's out here we're dividing by is our divisor. And we go through the process of long division. The number that we get as our answer is called our quotient. So 330 is always our dividend. Our divisors are 10, 4, and 5. And we have three different quotients, 33, 82, and 66. But our question is, in each of these problems, which of the divisors is actually a factor of 330? And our answer to that question is that 10 and 5 are factors. And we know that because when we divide, we have nothing left over. It goes in evenly. So our remainder in each of those cases where we have a factor is 0. So we're going to say we know those are factors because the remainder is 0. It divides in evenly. And today we're going to apply that concept not just to numbers but to polynomials. So we're going to scroll down the page. We're going to try to connect some concepts that we already know. We're going to take the cubic polynomial that we have in the first column and we're going to factor by grouping as we did in our last unit, pulling out our greatest common factor, which is x squared for the first terms and 5 for the next terms. And that leaves us with two factors, x squared plus 5 and x minus 2. That would mean our solutions are x squared equals negative 5, so x equals plus or minus I root 5, and x minus 2, setting that equal to 0, gives us x equals 2. Now, from our factor, we see that 2 is a solution. When we go up to our same function, written in function notation, and actually plug 2 into the equation, sorry, that's going to have to extend onto another line there, and we evaluate by plugging in 2, we get 8 minus 8 plus 10 minus 10. And that means when we plug in the value of 2, we get 0. And next, we're going to do some long division. I'm going to show you what it looks like. You don't need to repeat this process today because we're going to look for a shortcut. But we're going to take x minus 2 and we're going to divide that into x cubed minus 2x squared plus 5x minus 10. So this process starts with an answer of x squared, and then I multiply that by the divisor, x cubed minus 2x squared, and then I subtract both of those terms, and both of those cancel out when I subtract, so I drop down 5x, and the next answer in my quotient is 5. 5 times x minus 2, I'm going to write 5x minus 10. And then we're going to subtract both of those terms. And we end with 0. All right, so that's important. We did division by x minus 2, and we got 0 as a remainder. What all three things are telling us is that x minus 2 is actually a factor of the polynomial. And here's how we know. When we factored x minus 2, it was a binomial factor from grouping. We factored it by grouping, we saw x minus 2. When we evaluated by plugging in the 0, which was 2, that gave us 0. And then we divided, and we had no remainder. So all of these things are telling us something important about x minus 2. It's a factor. The factor of x minus 2 gives us a 0 of positive 2. And when we divide that polynomial, because it is a factor, we have no remainder. So that long division process that I did, we're going to try to speed up a little bit more quickly. But what we just saw there is going to rely on the factor theorem and the remainder theorem. So the factor theorem tells us that x minus h, this linear binomial, is a factor of the polynomial that we're looking at if and only if we plug in that 0 and get 0. So what that means is that we plug in the 0 and we get 0. Attached to that, if we divide by that factor, because it is a factor, the remainder will equal 0. So we're all about the zeros. And what we see in the factor theorem is that relationship that we looked at on our quiz. The factor is x minus the number. When we go to plug it in, we use the opposite of that. That'll be important for us today. So we're going to do division. We're going to look for those remainders of zeros. We're going to do it with synthetic division, which speeds this process up. We can do synthetic division if we have a linear binomial. So we know what those words mean. X to the power of 1, and it has 2 parts. So x minus 3, x plus 5. That means we can use synthetic division. When we do this operation, we're actually going to use the 0 that would come from the factor. So if we see x minus 3, we're going to use 3. If we see x plus 5, we're going to use negative 5. We're only going to look at the numbers of the thing we're dividing into, the dividend, and it has to be in standard form, highest to lowest. And if we're in standard form and any of our x's are missing on the way down, we're going to use placeholders. That'll make more sense in a minute. So as you're looking at this first example, here are the steps. They're all written out. I'm just going to narrate them as we do this first problem. We have 2 parts. The first polynomial is our divisor. I apologize. It is not divisor. It is our dividend. And we're dividing by x plus 2. That is our divisor. When we set up synthetic division, I always draw a long L to keep myself organized. And then I have a little shelf over here. And on that shelf comes the 0 from the divisor, which is negative 2. So that's where the negative 2 is coming from. It's the 0 from that factor. The numbers that are next to the negative 2 are the coefficients from our polynomial. So I look at my polynomial and I ask, is it in standard form? It is. X to the 4th, then x squared, then a number. That's in the right order. But between x to the 4th and x squared, there should be an x cubed. There's a missing term. That's where the 0 comes from. The 4 is the coefficient on the leading term. The x cubed is missing, so we say there are 0 x cubes. There are negative 6x squareds. And then the regular x's are missing, so there's also a placeholder there. And then our constant, which is 5. So this is the setup at the beginning. Our big L, our 0 from our divisor, and all the coefficients in a line next to that in descending order, as they would be written in standard form. Then our first step is to drop down, bring down that first coefficient. So it will never change, drop down a 4. And then we're going to multiply. 4 times negative 2. And we're going to write that answer, that product, right underneath the next coefficient, and we're going to add. 0 plus negative 8 gives me negative 8. Now we're going to repeat that process. The negative 8 times negative 2 gives us positive 16. Now we're going to add. Negative 16 plus positive 16 gives us 10. Now we're going to multiply again. 10 times negative 2 is negative 20. So we're going to drop down. 0 plus negative 20 gives us negative 20. And we're going to multiply again times negative 2. That gives us 40. And then we add 5 plus 40 is 45. All right. Now we need to write our answer and make our conclusion. On the top row, that is our dividend. It started with x to the 4th. Once we take out that negative 2, once we do the division, our quotient, our answer, is this line we've created, and it will be a power 1 less. So this is x cubed. Always go down by 1. And the last number in that row is our remainder. Here's how we write our answer or our quotient. We went from x to the 4th to x cubed. So these are our coefficients for our answer or our quotient. 4x cubed comes first, minus 8, and we're going to go in descending order of powers. X squared, then a 10x, and then a minus 20. So that's the polynomial we get when we divide, but we did have a remainder, so we write plus. And then we say we had 45 left over that still needs to be divided by x plus 2 because it did not go in evenly to that part. So that is our final answer, our quotient. Then to answer this question, is x plus 2 a factor? We're going to say no, and that is because we had a remainder of 45. So that is the reason for our answer. All right, we're going to do another example. This time we just have the L, but we're going to fill it in. For this problem, we have the basic setup, but we're going to fill in all the numbers. So we start with our divisor, x minus 1. We're going to use the 0 or the opposite right here, which is 1. We check our dividend, x cubed, x squared, x constant. It's in standard form, and there are no missing terms. So we put the coefficients in a line to the right of this stick. X cubed has a coefficient of 1, x squared has a coefficient of negative 1, negative 2, then 8. Now we always drop down our first coefficient, which is 1, and then we do our multiplication. 1 times 1 is 1. Negative 1 plus 1 gives us 0. Multiply again, 0 times 1 gives us 0. Negative 2 plus 0 is negative 2. And then we multiply again, negative 2 times 1 is negative 2. 8 plus negative 2 gives us 6. So we need to write our answer and make our conclusion. Our dividend started with x cubed. That means our answer is going to start with x squared, and this last number is our remainder. Here's how we write our final answer. It's going to be x squared. X squared plus 0x minus 2. You can leave the 0x in there. You can totally omit it. Totally up to you. Both are correct. And we have a remainder that still needs to be divided by 6 minus 1. We have a remainder, so no. That is not a factor. All right, you might try the next problem on your own, so pause the video, give it a shot, come back, and see if we get the same answer. I'll give you a minute to do that. So pause here. All right, welcome back. Let's check out your answer. We're going to set up our long division. This time we'll have to create our space. X plus 4 is our divisor. We're going to use -4. We check out our dividend in standard form. Looks good. 4, 3, 2, 1, none. All of our x's are present. We don't need any placeholders, so we're going to write 3, 12, -5, -18, and 8. Of course, while you're doing this, you're welcome to use a little blue calculator. Drop down your 3. Drop down the first coefficient. Now we're going to multiply. 3 times -4. That is -12. We add those together, and we get 0. Let's multiply again. 0 times -4. Still 0. -5 plus 0. -5. -5. There we go. Now we're going to multiply -5 times -4. It's going to give us 20. -18 plus 20 is 2. Then we're going to do 2 times -4, which gives us -8. And 8 plus -8 is 0. So let's write our answer. Our dividend was x to the 4th. So our quotient, our answer, is going to start with x cubed. And here's our remainder. When we write our answer, start with 3x cubed and go down in powers. 0x squared minus 5x plus 2. That's a stray mark up there next to the 2. And then we have a remainder of 0, so we don't need to add anything. And finally, we can make this conclusion: yes, x plus 4 is a factor because we had a remainder of 0. So the last thing we're going to look at is using the remainder theorem to evaluate what happens when we plug 3 into this polynomial. Just to compare, see how that works. Other uses of synthetic division. So first, we're going to straight up evaluate it. We're going to plug 3 in and see what we get. So we're going to square 3. We're going to multiply 9 by 3. And then we're going to subtract 16. So we'll get 9 plus 27 minus 16, which is 36, minus 16, which is 20. So 3 equals 20. The remainder theorem tells us if we set up synthetic division with 3 and this polynomial, which goes 1, 9, -16, our remainder should also be 20. So I'm going to drop down the 1. 1 times 3 gives us 3. 9 plus 3 is 12. 12 times 3 is 36. And -16 plus 36 is 20. And as we discovered, that last term in synthetic division is our remainder. So we can see here, those are the same. That's the remainder theorem. Either way, when we plug in 3 or we divide by x minus 3 using synthetic division, we get a remainder. So x minus 3 is not a factor of the polynomial. Now that you've completed the notes, you need to practice on your own. So you have a must do. You must do the EDIA assignment. It's called Synthetic Division Formal Formative. You can go to LCPS Go and search EDIA, or go to our Schoology folder, Unit 4, Day 4, and find the link. There's also paper practice attached to your notes. That's optional. There's an answer key in Schoology if you feel like you need more practice or you want to see some more examples, but you do need to go do the EDIA.